We're going to continue with limits at infinity, but we're going to look at some more difficult problems today. The first problem gives me a hint. You always want to use the hint whenever it's given to you. And the hint says, let x be 1 over t, and then find the limit as t approaches 0. So we're going to go ahead and do that. The limit as t approaches 0, and our x is 1 over t. Then we have tangent of 1 over t. What this ends up giving me is 1 over t times this 1 divided by 1 over t is actually 1 times t over 1. So this would be the tangent of t. I don't know a whole lot about tangents, so I'm going to change it to sine and cosine. Sine of t over cosine of t. Now, if I go back and I think about some of the things that we've talked about earlier this year, I actually could rearrange this. So it says sine of t, I'm moving this over here, over t times 1 over cosine t. Now I can use my properties of limits, and I can separate and think about each one as a separate entity. So I've got the sine of t over t times the limit as t approaches 0 of 1 over cosine of t. This one is one we're supposed to memorize, and we know that it approaches 1. And then we have times. We did this one earlier, so if I put 0 in here, I get 1 over, what is the cosine of 1? Or cosine of 0? The cosine of 0 is 1. So we end up with our answer of just 1. In the next problem, again, I have another hint, so we want to make sure that we use the hint. And it says, express this as a denominator of 1 and then rationalize the numerator. So I will do that. So that means I'm going to be multiplying by 2x plus the square root of 4x squared plus 1 on the top. And on the bottom I have 2x plus the square root of 4x squared plus 1. What this ends up giving me then is the limit as x approaches infinity. And I'll go ahead and start multiplying those things together. I get 4x squared. And then the outer terms fall out. So I have minus 4x squared plus 1 all over 2x plus the square root of 4x squared plus 1. Well, looking at this a little bit closer, I have 4x squared and I have a negative 4x squared. So I now have really the limit as x approaches infinity of negative 1 over 2x plus the square root of 4x squared plus 1. Now if I just start plugging in infinity down here, I'm going to get a really, really large number. I'm going to have negative 1 over a really, really large number, which means it will go to 0. In my next example, I have another table, and we can use the table function of our calculator to help us out. So we'll put this in our calculator, and then we'll hit the table button, and we'll go ahead and complete the table. I'll just go ahead and tell you what the table ends up giving you. You end up with 200. The next one you get 0.348. Then we get 0.101. Then 0.032. Then 0.010. 0.003. And then finally 0.001. Easiest thing to do again is use that table function on your graphing calculator. So once we've completed the table, it says to check using your graphing calculator. You should see that the limit as it approaches infinity, or as you approach infinity, it should be getting closer and closer to 0. And then we'll do this analytically. Finding the limit analytically, I'm going to use the L'Hopital's rule, which says I keep the highest degree on the top and I keep the highest degree on the bottom. This on the bottom is actually x to the 3/2 power. So when I simplify this, I end up getting the limit as x approaches infinity of 1 over x to the 1/2. So when I plug in infinity, I get 1 divided by a really, really, really big number, which means it's going to infinity. All this is meant to do is show you either way, if you do this numerically, if you do it graphically, or if you do it analytically, you still end up with the same answer as of 0. I'm going to take you through a few more of these examples, so I'll move as quickly as I can. We're going to go ahead and find the x-intercept. Remember, that's where y equals 0. When we cross multiply and solve that, we end up getting x is 0. So that means the point is 0, 0. I'm not going to go ahead and find the y-intercept because I know the y-intercept is also going to be 0, 0. So we just have one intercept and it would be 0, 0. The next thing I'm going to look at are my asymptotes. So we have vertical asymptotes when the bottom is equal to 0. So I'll be looking at this bottom part and setting it equal to 0. So that would be when x is plus or minus 3. So I have two vertical asymptotes, one at x equals 3 and one at x equals negative 3. The horizontal asymptotes are where the limit as x approaches infinity. So I keep the highest degree on top and the highest degree on the bottom. Notice it is a negative x squared. When I cancel or simplify this, I end up getting 2 over negative x. So as this number gets really, really large, 2 divided by a really, really large number goes to 0. So my answer would be y equals 0 for my horizontal asymptote. Now I really should check the limit as x approaches, and I need to go back here and adjust these on the last one as well. I should have actually been finding the limit as x approaches plus or minus. So the limit as x approaches positive infinity and as x approaches negative infinity. That doesn't do anything to these problems. The only time that this is going to happen is if we have a square root problem, which I will show one of those to you here in a little while. So I'll quickly sketch the graph. I have a vertical asymptote at 3 and another one at negative 3. I have a horizontal asymptote at y equals 0. I know that I have an intercept of 0, 0. If I would check all the other parts of this, I would be able to come up with more of the sketch, but we're not going to do that in this problem. We'll just use our graphing calculators and sketch this graph, and then we'll talk about the symmetry. This is actually symmetric about the origin, and how I know that is that the point 1, 1, I guess that isn't necessarily 1, 1. Let's see, the point, let's see, this would be 2 on top if I was to put 1 in for x, and I'd have 8 on the bottom. So I would actually have 1/4. So the point 1, 1/4 is on the graph, and so is negative 1, negative 1/4. And we can see that if I put negative 1 in here, I'd end up with a negative 2 over, that would be 9 minus negative 1 squared, which would be 1, so you'd end up with negative 2 over 8. So because the x comma y and the negative x comma negative y, both of those are ordered pairs of the graph, this is symmetric about the origin. Symmetric about origin. That's probably one of the hardest symmetries to find, but typically if it goes through 0, 0, it will be symmetric about the origin or symmetric about something. I have 2 more of these examples, but I'll have to do one more video for those. 2 more examples of these, and since these take a while, I will be moving at a rather quick pace. We're going to find the x-intercepts first. The x-intercept is where we plug 0 in for y. When I do that, I end up dividing by 4, and I have 1 plus negative 1 over x squared. Move that to the other side. Cross multiply. So I get my x to be plus or minus 1. So I have 2 x-intercepts, 1 at negative 1, 0, and 1 at 1, 0. The next thing I want to look for is the y-intercepts. So the y-intercepts where it crosses the y-axis. So we'll plug in 0 for the x. When I do that, notice how I end up with a undefined value here. So there is no y-intercept. Moving on then, we would see there is no y-intercept because if I look at this closely, I've got vertical asymptotes, and vertical asymptotes occur where the bottom equals 0. So I would have a vertical asymptote at x equals 0. And then lastly, I would have let's see if I can fix that really quick. A horizontal asymptote I'm going to take the limit as x approaches infinity as x approaches plus or minus infinity. So I will look at each part. So I'd have 4 times 1 minus, if you putting positive infinity or negative infinity here, it doesn't really matter which one. It still gives you the same number of 0. So we'll end up with the value of 4 for our horizontal asymptote. So we have a horizontal asymptote of 4, we have a vertical asymptote of 0, and we have these 2 points to work from. So when I sketch this graph, I will end up drawing in my vertical asymptote, my horizontal asymptote. I have an intercept of 1, 0, and one at negative 1, 0, and so my graph ends up looking like this. This is symmetric about the y-axis. It's symmetric about the y-axis because if I fold it in half on the y-axis, I will end up with the same graph. Last one of these examples, I'm going to go ahead and find the x and y intercepts. If I do that, I end up getting x over square root of x squared minus 4. Well, that tells me that there's an x-intercept at 0. However, if I actually look into this a little bit further, and I plug 0 into the bottom, I end up with an imaginary number on the bottom. There will end up being no intercepts for this problem. We do not have any intercepts, but we do have vertical asymptotes. The vertical asymptotes occur where the bottom equals 0. So those would occur at plus or minus 2. 2 will give me a 0 on the bottom, and so will negative 2. And lastly, I'll look at the horizontal asymptotes, which is what I really want to look at in particular in this problem because it's one with the square root. So I'm going to take the limit as x approaches plus or minus the square root, or plus or minus infinity. Highest degree on top is x, the highest degree on the bottom is the square root of x squared. Now remember that we are going to simplify this, and since we are taking the square root of something, we actually get plus or minus the square root of x on the bottom, which means that these limits are 1 or plus or minus 1. So we have horizontal asymptotes at y equals 1 and horizontal asymptote at y equals negative 1. We're going to quick sketch the graph of this, and when I do that, I'll have vertical asymptotes, horizontal asymptotes, and I have no intercepts, so no points to go off of. So when I look at my graphing calculator, this is what I end up with. Now I will tell you that this is symmetric about the origin, and you can check that because all the x, y ordered pairs of this graph and all the negative x and negative y they're both ordered pairs of this graph.